So, good morning, friends. In the first lecture, we will see the addition principle, or we can say it is addition or sum rule principle. The second one is already we have discussed the product rule or multiplication principle. So, in this lecture, we will be discussing two fundamental principles of combinatories. So, first one is the subtraction principle, and second one is division principle. So, these principles provide essential methods for counting, which are widely applicable in various mathematical and real world problems. So, the first is the subtraction principle. So the subtraction principle, also known as the principle of complement, and it is the technique for counting elements in a set by subtracting the number of elements in its complementary set. So formally, the principle says that let A be a set and let U be represent a universal set that contains A. So the complement of set A is denoted by A dash or A bar, and it is defined as complement of A is defined A dash is equals to the set of all x such that all these x are belongs to U, such that x does not belongs to set A. So this set is a complement of A. So according to the subtraction principle, the number of elements in A is denoted by n of A, and it is given by n of A is equals to the number of elements in a universal set minus number of elements in a complement of A. So this method us to find the number of elements in A by subtracting the number of elements in A dash. So from the total number of elements in the universal set U. So let us see here one example on the above principle, and the first example is so let us see here. It is the example on non-defective items in a factory. So the problem of this example or statement is a factory produces 1000 items and 50 of them are found to be defective. How many items are not defective? So if we observe the statement of this example, it is very easy to find out. Just you have to subtract defective items from the factory produces items. Yes, so just you can mathematically you can write here denote, let A represent the set of non-defective items and U represent the set of all produced items. So look at here, and A dash represent the set of defective items. So we know that the number of elements in a U is 1000, and the number of elements in A dash means the complement, it is 50. Therefore, by using the subtraction principle, we get n of A is equals to n of U minus n of A dash. It means just you can put the values of this n of A means the number of elements in universal set minus the number of elements in complement of that set A. So this is 1000 minus 50 is 950. So the number of non-defective items are 950. Yes. So look at here the second problem or second example on this subtraction principle. So in a school there are 200 students, 150 of them have a library card, and how many students do not have a library card, that we have to ask here. So this is the example of student without a library card. So here also in a solution you have to denote U, A and A dash, and just you can find the solution of the above problem. So let A represent the set of students without library card, U represent the set of all students in a school, and A dash means the complement of A represent the set of students with a library card. So we know that n of U is 200 and n of A dash is equals to 150, and therefore the according to the subtraction principle, n of A is equals to n of U minus n of A dash, and this is equals to, you know, the number of elements in U is 200, the number of elements in complement of A is 150. So we get the 50 students do not have a library card. Yes. So look at here the example number 3, and so it is the example on household without pets. So see, a survey of 500 household reveals that 320 households have a pet. So the question is, how many households do not have a pet? So look at here the statement of this example. We have to represent, or we have to denote the set A represent the set of household without a pet, and what is U? U represent the set of all surveyed households. Yes. So automatically you can get the A dash, and it is represent the set of households with pet. So just you can denote these. We get the n of U is 500, and n of A dash means the complement of A, and it is equals to 320. So by using the subtraction principle, just you can calculate it. We get the 180 households do not have a pet. Yes. So I think all of you are understand very well this subtraction principle. Just see here again one example on this one. So this is the example number 4. A conference was attended by 800 participants. Of these, 650 participants registered on a line before the event. Yes. So the question is, how many participants registered on site? Yes. So you know how to find the solution of this example. So look at here, this is the solution. We have to denote first A is the set of participants who registered on site, and U represent the set of all participants, and A dash represent the set of participants who registered online. Yes. So by using this given things, you can write n of U is 800, n of A dash is 650. Just you can subtract, we get the 150 participants registered on site during the event. Now I think this is a sufficient examples we have solved here on the concept of subtraction principle. Now look at here, the next principle is a division principle. Yes. So see, the division principle, also known as a quotient principle, it is used to count the number of ways to perform an action where a set of elements is divided into equal sized parts. So in essence, if we have a set A and we partition it into k equal sized parts, then the number of elements in each part is found by dividing the total number of elements by number of parts. So this is expressed mathematically as k is equals to n of A by m. So look at here, where n of A is the total number of elements and m is the size of each part. So I think, are you understand the concept of division principle? Yes. So let us see here one example on this division principle. Just a minute. So this is the statement. You have 100 candies and you want to distribute them equally among 5 children. So how many candies does each child get? So look at here the solution. You know, we have to denote A be the set of 100 candies and K represent the number of candies each child gets. Yes. Since there are 5 children, we have m is equals to 5. Yes. So the number of children m is equals to 5. So according to the division principle, K is equals to n of A by m, and we get the answer is each child gets 20 candies. Yes. So look at the second example on this division principle. So this is the statement. There are 24 people and you want to sit them at 6 tables with an equal number of people at each table. So the question is, how many people will be seated at each table? Yes. So again, just you have to represent A with a set of 24 people and K represent the number of people seated at each table. So here given that there are 6 tables, yes, so that's why M is equals to 6. So using the division principle, you can write K is equals to N of A by M, and so which is equals to 24 by 6, and the answer is each table will have 4 people seated. Yes. So see here the next example on this division principle. So this is the statement of the example, and this example is on arranging books on shelves. So a bookstore has 480 books and they want to place an equal number of books on 12 shelves. So how many books will be placed on each shelf? So look at here the solution of this example. We have to represent A is the set of 480 books and K denote the number of books on each shelf. Since there are 12 shelves, we have M is equals to 12, and so according to the division principle, you can write 480 divided by 12, which is equals to 40, and thus each shelf will contains 40 books. Yes. So see here the summary or conclusion of this today's lecture. In this lecture, we have explored 2 important counting principles in combinatories. The first one is the subtraction principle, which allows us to count elements by subtracting the number of elements in a complementary set. And the second one is division principle, which enables us to divide a set of elements into equal sized parts and count how many elements are in each part. So these principle forms the foundation for solving many real world problems in combinatories and beyond. So this is sufficient for today's lecture. We will stop here. Thank you.